Section 3.2 is solving systems algebraically. I can solve linear systems algebraically. Big ideas here. A system of equations can be solved by writing equivalent systems until the value of one variable is clear. Then we can substitute to find the value of the other variable. If the equations of two systems are equivalent, then a solution of the system that is easier to solve is also a solution of the more difficult system. So here we're going to try to find the solution of the system of equations. Sometimes when we do this, we don't necessarily have graph paper handy, or when we graph them, we get a point in between two values. And rather than guesstimating what that value is for our x and for our y, we can use algebra and solve algebraically. And that's what we're going to do here. We're going to use substitution. So the first thing I'm going to do is I'm going to solve one of my equations for one of my variables. Doesn't matter which equation, and it doesn't matter which variable. If I look here though, this y looks like it's going to be the easiest to solve for because its coefficient is just 1. So to solve for y here, I can subtract 2x from both sides, and I get y equals negative 2x plus 10. Now that I know what y is, I can take that y value and substitute it in my second equation, have to substitute it into my other equation. Okay, it has to go into my opposite equation for the variable I solve for. Here I solve for y, so I substitute in for y. I take 3x plus 4, and then instead of putting a y, I put what y equals. Negative 2x plus 10 equals 12. Now we're just going to solve for our variable. The only variable I have left is x. So on my left side, I'm not completely simplified. I have to distribute first. Then we can bring down the rest of the problem. Combine like terms. Add or subtract to get rid of anything that doesn't have our variable. Then multiply or divide. And I get 5.6 for x, or 28 over 5. Now that I know what that x is, I can find my y. Remember, when we solve a system, I have two variables, x and y, so I need to have a solution for both. I know what x is. I can substitute back into the equation I solved for to find y. We can actually substitute into any equation that has both an x and a y, but this one's going to be the easiest to substitute into because we've already solved it for y. So y equals negative 2 times 5.6 plus 10. Negative 11.2 plus 10. Y equals negative 1.2. So my solution here is the ordered pair x, y. 5.6, negative 1.2. So we could have done this graphically if we were using something like Desmos, where we can select a point and get the exact answer. But if we were doing it by hand, we would have had something in between two boxes. It would have been like 5.6, negative 1.2, somewhere in here. And we'd have had to guesstimate what that is. And we don't want to do that. We want to have an exact value here. So we can use algebra and substitution. Feel free to pause here and give this a try if you'd like. When we solve here, it does not matter which equation or which variable. So I know in the last example I solved my second equation for y. But here, if we look, my first equation for x is going to be easiest here because I don't have a coefficient, which means my coefficient's just 1. I'm not going to have to divide. So I can just subtract my 3y and get x equals 5 minus 3y. You can solve for any variable you want to, but if we pick the one with the coefficient of just 1, we're less likely to have fractions or decimals that we're going to have to distribute through. So it's going to be probably the cleanest option there. Now that I know what x is, I can take that x value, what it equals, substitute it into my other equation, again has to go into our opposite equation, for the variable we solve for. We solve for x, so we plug it in for x. negative 2 times, we know x is actually just 5 minus 3y. Bring down the rest of our equation, minus 4y equals negative 5. We'll distribute first. Negative 10 plus 6y minus 4y equals negative 5. Combine like terms. Add or subtract. And then multiply or divide. And I get 2.5 for y. Now that I know what y is though, remember we need the entire ordered pair. I have two variables here, an x and a y. So I have to have a value for both an x and a y. I can substitute that in for y. X equals 5 minus 3 times 2.5. X equals 5 minus 7.5. So x equals negative 2.5. My ordered pair then is negative 2.5, 2.5. And if I substitute these back in, both equations should be correct. So what I get on the left, I get on the right for my top equation and for my bottom equation. In example 2 here it says, a music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials are shown in the advertisement on page 143, and I've put that picture here as well. What is the cost of each lesson and the one-time fee for materials? So, prices include a one-time fee here. So I know that I'm going to have a fee for 6 lessons, and 6 lessons, it's going to be $300. The same one-time fee and 12 lessons is going to be $480. So here's my system. Okay, 6 lessons and a fee, $300. 12 lessons and a fee, $480. Does not matter which equation we solve for, but here it looks like f is going to be easiest to solve for. So I'm going to subtract 6L and get f equals 300 minus 6L. Okay, now I know what f is, so I can substitute that into my other equation for f. 300 minus 6L, bring down everything else, plus 12L equals 480. We can combine like terms. Add or subtract. Divide by 6. So lessons are going to be $30 a piece. Now, we still need to figure out how much that fee is. Okay, so just because we get $30 per lesson, we still have f's that we need to solve for. So I'm going to plug that 30 in up here for L. F equals 300 minus 6 times what each lesson costs. And my fee is going to be $120. And if we plug it in to check here, guys, 120 plus 6 times 30, 180 plus 120 is 300. 120 plus 12 times 30, 360 plus 120 does give me 480. So it does check if we plug it in and solve. Now, feel free to pause here and give this a try if you'd like. An online music company offers 15 downloads for $19.75 and 40 downloads for $43.50. Each price includes the same one-time registration fee. What is the cost of each download and the registration fee? So let's say we're trying to figure out which one's going to be the better deal. per download. Maybe we don't necessarily need all 40, maybe we only want like 25 or something, but we're still trying to figure out what's the best deal here. So we want to know how much it actually breaks down to be the cost per download. So for my first option, I have a one-time registration fee for both, and I get 15 downloads. So 15 times some cost D, we don't know, the cost per download, equals $19.75. Or we have that same fee plus 40 downloads. So 40 times the price per download to give us $43.50. And here's my system of equations. First thing I'm going to do here is I'm going to solve for f. I'm going to use the top one because 15 is smaller. It gives me positive values when I combine like terms, but it doesn't matter. We can use either of them. But if we solve for f, it's going to be simplest because our coefficient is a 1. And we could have done that in either equation. So f equals 19.75 minus 15d. Now I know what f is, so I can take what f is and plug it into my second equation for f. I get 19.75 minus 15d, then I bring down the rest of my equation, plus 40d equals 43.50. Combine like terms. Add or subtract to get our variable term by itself. Here we get 23.75. Then multiply or divide to get d by itself. And I get 95 cents per download. Okay, it wants to know what is the cost of each download and the registration fee. So if I know the cost of a download is 95 cents, I can find my fee by substituting that in. So my fee is going to be $19.75 minus 15 times D, which is 0.95. So we multiply first. And then we can subtract. Or you could have just typed that all right in, and we get $5.50. So $5.50 fee and 95 cents per download. We can use the addition property of equality to solve a system of equations too. If we add a pair of opposites or subtract identical terms, we can eliminate a variable. So in example 3, if we look here, neither one of these is going to be particularly easy to solve for a variable. But if we notice here, 4x and minus 4x are opposites. So what I can do instead is I can add up these two equations. 4x plus negative 4x is 0 x's. 2y plus 3y gives me 5y. And 9 plus 16 gives me 25. And I can do that because essentially I'm adding the same thing to both sides. They look different, but what I'm really doing is I'm taking negative 4x plus 3y, that's a 16, and I'm adding it to 4x plus 2y. And I'm taking my 9 and adding a 16. So this negative 4x plus 3y doesn't look the same, but it equals the same thing. So we can add the same thing to both sides of any equation and produce an equivalent equation. And what that lets us do here is it solves for one of our variables. Now I can solve for my other variable again by substituting. I know that y is 5, so I substitute in. And solve. And I get x equals negative 0.25. So my ordered pair is negative 0.25, 5. So again, if we have opposites, we're going to try and eliminate a variable that way. solve for a variable, and then substitute it in to solve for our second. And I'll continue in another video.